Hi everyone. In this video, we'll look at some more tricky examples of integration by parts. When you look at this problem, it's not immediately clear why integration by parts would even be relevant, because that method requires us to have a product of two functions. But here's a useful trick. We can always consider that a function was multiplied by 1, and in that way we can form a product of two functions where there wasn't any previously, at least there wasn't obviously one previously. So with this in mind, pause now and see if you can solve the rest of the problem from here. If you're ready to proceed, let's continue. The correct solution is to assign ln x as f and 1 as g prime. The reason this works well is because when f becomes f prime, our logarithm disappears entirely. The price we have to pay for that is that g prime becomes a little more complicated when we anti-differentiate it. But when we weigh that against the advantage of getting rid of the logarithm, I'd say this is a worthwhile trade-off. But to be certain, let's make use of this formula and work through the remaining details. So, starting with the integral we want to calculate, we can say that this is equal to f times g minus the integral of f prime g. And this resulting integral is really as easy as it gets, because you can literally cancel x with 1 over x and end up with the integral of 1. The antiderivative of 1 is just x, just don't forget the plus c, and you're done. Let's try another example. Pause and see how far you can get on your own, and when you're ready, let's look at the solution. Once again, the trick is to introduce a factor of 1 so that we can integrate by parts. There's no way to just know that you should do that, but it's somewhat motivated by the fact that I would prefer to work with the derivative of arctan rather than working with arctan itself. And I can do that provided I assign arctan as f, with the trade-off being that I would need to assign 1 as g prime. Let's see how this goes. First, we change f into f prime using the arctan derivative formula. Then we change g prime into g by taking an antiderivative. After doing that, our new integral is of f prime times g, which is as you see here, so you can pause and check these details as necessary. All I did there was apply the integration by parts formula. But something you shouldn't forget about this question is that we're taking the integral from 0 to 1. So the entire right-hand side also needs to be evaluated from 0 to 1. But before we do that, let's finish finding our antiderivative first. Notice that with a slight modification, the integral we have now is of the form f prime over f. So as always, we can evaluate that as the natural log of the denominator with an absolute value. In this case, I've ignored the absolute value, knowing that 1 plus x squared is already a positive number. Now that we have our antiderivative, we're ready to evaluate from 0 to 1. So first plug in x equals 1, then plug in x equals 0 and subtract the results. This entire second set of brackets has a value of 0, so we can just forget about that and focus on the first set. And as a final step, you can use the unit circle to show that arctan of 1 has a value of pi over 4. This isn't the nicest looking answer, but it is the best we can do, so presenting it this way is perfectly fine. That's all for now, so I'll wrap things up here and see you next time.